now we're going to look to review over two sample hypothesis tests. We're going to focus on proportions, but you could do the same thing with the means as well as proportions. And the key part here is we're going to do some of this by hand, not by running the actual test through the calculators, so we can get a better understanding of the connection between confidence intervals and hypothesis tests. So what we will start with is we'll first do the basics of the connection between confidence intervals and hypothesis tests. Remember a confidence interval. Let's just choose some easy numbers to work with. Let's say we have a confidence interval that it goes from 5 to 15. So we're saying that we are 95. Let's go ahead with a 95% confidence interval. We're 95% certain that our mean would be between 5 and 15. Or if we're doing proportions, we could call these percentages, 5% to 15%. And so we would write it like this, and we'd have what we're working with two samples is the difference between the means or the difference between the proportions. So P1 minus P2. We'll just list these as percentages. Again, you could also make them just numerical if you wanted to use means. What this tells us, remember, is that the point estimate would be halfway between this, because a confidence interval is symmetric. So where would be halfway between 5 and 15? Well, you could say, well, that looks like probably 10%, and you'd be correct. If you wanted to do the mathematics for that, you take 5 plus 15 and then divide by 2. That gets you halfway between as well. That's 20. 20 divided by 2 is 10. So we were correct here. When we have this set up, the margin of error is the distance from the point estimate in the middle to each of the boundaries. The margin of error is a plus or minus, right? So over here, if we add 5, 10 plus 5 is 15. Over here, if we subtract 5, 10 minus 5 is 5. So our margin of error is going to be 5% here. And what we're getting is on a confidence interval, if we put the normal curve or a t-curve is going to be similar like that. And this 15% is one boundary point. I'll use the yellow. And the 5% is the other boundary point, and the 10% here is in the middle. So we have a middle part that represents 95%. We're 95% confident that our mean is between these two. That's 95% of the normal curve. What's in the tails? So remember, confidence intervals is the middle part. The hypothesis test, we're going with the tails. So there would be a total of 5%, right? 95 plus 5 gives us 100%. And since we're doing a two-tailed test, we have half of that in each of the tails. But what goes with a 95% confidence interval, put it this way, is a 5% significance level. So that's at alpha, right? So the alpha is always in the tails of the normal curve. Confidence interval is always in the middle. So remember, the confidence interval is giving us usual values. What's usual? The tails are what give us our unusual. our extreme values are. And that's why we're able to reject when we're in that region, right? So this sets up a rejection region in the tails. And if we're not in the tails and we're in the confidence interval, then we fail to reject. So the middle region here, we'll label it all. This is the fail to reject. And over here in the tails, either this tail or this tail, that's if we're in those tails with our tests, our t-values, that's where we would reject the null. So let's kind of see how that works overall. Those are the basics. Again, did it with kind of easy to work with numbers. When it's a little harder to work with, we'll probably want to do the calculations to find the middle, to find, and again, what we would have done to find the margin of error, you could have taken 15 minus 10 to see that that's 5. Or you could have taken 5 minus 10. Well, that's negative 5. So there's our plus 5, our minus 5. That helps us do that. Okay. So let's go ahead and take a look at an example. I'm going to ask you on this, in testing the null hypothesis, P equals P1, which could also be the standard way we have it written is P1 minus P2 equals 0. Those are the same statement, because if their two numbers are equal, when you subtract them, you get 0. But this is the way we see it stated in our hypothesis tests. That's also what's happening here. So if we have this as our confidence interval, the question is, should we reject the null hypothesis and then explain? I'm going to make it a little bit bigger. You probably can see fine with the video, but sometimes in class it needs a little bit. But if this is our confidence interval, should we reject the null hypothesis or fail to reject? So I'm going to pause this for just a moment. If you can, well, actually, you're going to need to pause it. Try to think through it, see if you can get an answer, and then in just a moment, I'll come back and we'll answer it. Please pause. All right, now that we're back, hopefully you can see that this idea that P minus P2 is going to be equal to 0, what we're asking then is 0 in this interval? Again, if you sort of set it up as a normal curve, goes up, and these are our boundaries, where would 0 be? Well, this is negative, this is negative. 0 is going to be further down so there's a boundary here and say a boundary here. 0 is going to be like over 0.04, negative 0.04. 0 would be like over here. We are in the rejection region. We are not in the middle part, right? So when we are not in the confidence interval, then we must be in the tail. And when we're in the tail, we reject H naught. So we could say there's evidence to show that they're not equal or that one is greater than the other. We didn't really set the whole thing up, but we can reject the null hypothesis. That's what we know for this one. Here's another example. Again, we're going to test the same thing. Here's our confidence interval. Should we reject the null hypothesis? Here's it a little bit bigger. Again, please pause the video. Think through this. Make your decision. And when you're finished, you can unpause. Please pause. Now we're back. Hopefully you did pause. So what's the deal here? Well, where is 0? Well, here's negative 3% and positive 7%. 0 has to be in between a negative number to a positive number. So again, if we draw our normal curve. Here's our boundary. Here's -3%. Here's +7%. Zero is going to be somewhere in here, probably a little bit closer over here. So here's 0. 0 is in the confidence interval. 0 is in the confidence interval. So it's not in the tail. So we fail to reject. H naught. Okay. And again, with each one of these, you could work to find what is the point estimate. And let's just go ahead and do that now that we've answered the main question. The point estimate is the middle point here in this interval, because remember the interval is symmetric. So you add the two together. I'm going to do it as 3% and 7%. And then you divide that by 2. So you get a +4 divided by 2, which is going to give you 2%. Right? So our point estimate will be 0.02. What is our margin of error? Margin of error. Well, you think of, since 0.02 is in the middle, how far from 2% to 7%? Take 7% minus 2%. It's going to give us 5%. Took -3 to 2%. That's also a distance of 5. So our margin of error is 0.05. A little bit of practice to see what we can do with these intervals. Again, I leave you to go ahead and do that for number 1. That's going to be helpful in our next question. So I'm going to erase this. Remember, you can always pause to see what you need to see. So let's go to the next one. Little advance. Give yourself a bonus for getting through this one. We have a confidence interval for a difference in proportions. We're given that from -0.02 to 0.08. The sample proportion for men, so this is P sub M and P sub W. So for the sample had 0.34 for men. So they were asked to find the maximum error and the sample proportion for women. Okay. Is there something else here? Okay. So what we have to look at, I think there should be, yeah, make it a little bit bigger so we can work with it. We want to get that, to get the maximum error estimate or the margin of error, we need to get the point estimate first, which is in the middle. Again, to do that, we add the two together. Negative, and I'll do it as percentage, -2% plus 8%. We're always adding them together. Divided by 2, that gives us 6. Divided by 2, so that gives us 3%. Just do it this way. So our point estimate is 0.03. And then just think how far from 3 to 8%? Well, you just take 8% minus 3%. That's going to be 5%. Okay. So our margin of error, which is this question, the first question here, maximum margin of error is, I'll just do margin of error, is 0.05. Okay, so that's one question. Now the sample proportion, notice what we've got is we've got P sub M minus P sub W is equal, in this case, to 0.03, because that's how we get the confidence interval based on the sample, right? So we know that the sample estimate, sample minus of men, P hat of the women, needs to be equal to 0.03. We know the sample proportion for the men is 34%. We have enough information here. So what do you subtract from 34 to get 3? You could think, well, that's going to be 31%. Or you could do all the math. Let's subtract 0.03 from this side, 0.03 from that side, and then you could add p hat to each side. This is algebra doing two things at once. This cancels. 34 minus 0.03 is going to give us 0.31, and that's going to be equal. These guys cancel here, so there's sample p hat sub w is 31%. Okay. So we can see how we can use point estimates for that. Would we reject the null hypothesis? That wasn't the question, but just we could throw it in here. We would not, right? Because negative 2% to 8%, 0 is going to be in here. In fact, pretty close in here somewhere. And so 0 is in the confidence interval. It's not in the tails. We would fail to reject this if this was a hypothesis test. So just giving you some ability to work by hand through these confidence intervals, get a deeper understanding. Hopefully that's the whole goal. Okay, oh, got that. We did all this. Okay, so let's look at another example. Hopefully will help us build more understanding. A survey asks a random sample of men and women whether they agree with a statement. The result of the survey is that 35% of the men, so that's a sample, right, and 43% of the women agree with the statement. The maximum error for the estimate for the difference in proportions is calculated to be 13.5%. So how would we find the confidence interval for the difference in proportions? So difference in proportion, you take the proportion of men minus the proportion of women from the sample, and that's going to give us the point estimate, right? So that's going to be 35% minus 43%, and that is going to be 8%, negative 8%, right? Because this is 43 is larger, negative 8%, so we could go with 0.8. That's in the middle. And so to get our confidence interval for the true means, the true proportions from the populations, we would, for this end, we will add 13%, 13.5. You add these together, you get 0.055. Let's just, sometimes I go visually, negative signs and everything, it's hard to, so we'll just put a negative 0.08 plus 13, oops, 0.135, 0.055, okay? And then to get the far end, the lower end, the left end, we take this negative 0.08 and we subtract 0.135. We're going to get 21.5. And again, we can double check that with a negative 0.08 minus 0.135. We get 21.5. 21.5% or 0.25, and it's negative. Okay, so there's our confidence interval. Should we reject the null hypothesis? Well, we're going from a negative to a positive, so that means 0 is in the middle here. 0 is in the confidence interval. It's very close to this side. Here's 5%, so closer to this side. But M minus PW equals 0 is in the confidence interval, not in the tails. So we fail to reject. Okay. Again, we can, and this is my explanation, it's good enough. Okay, so looking at confidence intervals, we can think about how it relates to a hypothesis test. Now I want to go a little bit further, a little bit deeper, a little bit further back, and come back to, I think this is probably chapter 2 or 3, maybe 4, where we were doing conditional probabilities. And I want you to see where we were using these frequency tables in a certain way to calculate proportions. And so let's go ahead and do this one together. Again, I guess I didn't do it last time, but before I start into this, you should pause it and try it on your own. Then you can follow along. Some of you may choose not to do that, and that's okay, but try to give this your best shot. Okay, so now we come back, and hopefully you pause, work through it. Let's see what you came up with. An advertising agency conducted a random survey of adults, asking their primary source of news and educational level. So their educational levels are listed here. They did not graduate from high school. They did graduate from high school, but not college, or they graduate from college. Primary source of news is either newspapers, televisions, or internet. Test the claim that the proportion of college graduates, so maybe since we're talking about college graduates, we'll just sort of highlight this column or encircle, in box, whose primary news source is the internet, so we're focusing on internet, is higher than, we're going there, that's higher than, greater than, that's the greater than symbol, right? Read from left to right, is greater than the proportion of high school but not college graduates, high school but not college, so this is the second group we're looking at, whose news source is also the internet. I use the p-value method with significance level 0.01. P-value method, what we need is, since we're doing proportions, think of this as successes and failures. What is the number we need? Well, if we look at this overlapping region, internet comes this way, and the ones that we have in the middle, right here and here. So proportion 1 is going to be, and again, the way they ask is college graduates actually comes first. So this is going to be proportion 1. This one here will be proportion 2. So proportion 1 is college graduates. The number that use the internet is 245. So that's the number of successes. Sample size are the total college graduates is 656. For proportion number 2, we've got high school but not graduates but not college. Again, 401 is their success rate number. 401 use the internet out of a sample size of 1,271. And now we have enough information to actually go ahead and run this hypothesis test through our calculator. We're going to come back here. We're going to go to inference. We're going to go to tests, and we're doing 2 proportions. The null hypothesis is always that the difference is equal to 0. This is where we get the alternative. The alternative is that the college graduates is higher than the proportion, greater than, So when we read it that way, we set it up here. And again, we just got to be careful which one is P1 and P2. If you read it from the table, you might, and I did this the first time, and I actually said, oh wait, that's wrong. So we have to read the question. They're talking about college graduates first, so those would be our proportion one. Okay, so we set that up, and then from here on in, we just enter our statistics. 401 successes for proportion one. Sample size is one. Sorry. Oh, wait. See, looking up here instead of down here, so easy to mess up. 245 for proportion one successes out of 656. For proportion two, oh wait, I'm in the mean. Oh yeah, we're in the proportions, but we put in the number. We don't put in an actual proportion, right? X2 is going to be 401, number of successes, and the sample size is 1,271. Okay. Significance level that we were given was 0.01, so we'll put that in there. And then we have done the test. Now be careful, these are the proportion, so this would be the 37% are college graduates who use the internet, 31.5% are high school graduates who use the internet. This is the pooled proportion. What we're looking for is the p-value right here, 0.005. That's what we want to compare to the alpha level. Alpha we were given as 0.01. P were given as 0.0053, if you want. But you can see that the p-value is smaller than alpha, so we reject. Okay. We can also go to the next screen, which will give us our picture. And we are doing a right tail test, the higher than. And as we zoom in on this, we see that our p-value does put us completely in the rejection region. So we reject H naught, which is that they were the same, and we can then say there is evidence to believe that their proportion of college graduates who use the internet is higher than the proportion of high school students. Okay. Now in class we didn't quite get to these last ones, but I'm going to go ahead and do one more example so we can go through that together. One more practice, and then I'm going to show you the link where these questions came from. And if you hit the link, if you click on these little icons at the end, it will actually give you the answer, a little bit of a solution guide too. And so hopefully you can practice more if you'd like. Okay. So now for 16, we're given that Lipitor is a drug used to control cholesterol. Okay. In clinical trials of Lipitor, 94 subjects were treated with Lipitor, and 270 subjects were given a placebo, a fake pill, something that doesn't work. Among those treated with Lipitor, 7 developed infections. So what we're trying to see is does Lipitor have a side effect that might make people more prone to infections? Well, then we also check among those given a placebo, 27 developed infections. So now we're going to use a 5% significance level to test the claim that the rate of infections was the same for both. And if we can, then, so are they the same? So the P1, P2, proportions would be equal to 0. That's our claim. And so basically that there are no differences. So that's always going to be the null hypothesis. The alternative would be that they are not equal. So P1 minus P2 is not equal to 0. Okay, so let's go ahead and get this set up. Not much more calculations that we need to do. Two proportions. Null hypothesis is always that they're equal. So the alternative is going to be that they're not equal. Not greater than, not less than, but just not equal. Set that up, a two-tailed test. Okay, and we'll do with, since they gave it to us in this way, Lipitor had 94 subjects. So that's their sample size. So this is going to be in 1. 270 is going to be in 2. The success rate, I successfully got an infection. Our infection rate was 7. So that's going to be your X1 down here, 7. And your X2 is going to be the 27. So X1 is 7. N1 sample size is 94. 200 X2, that's the 27. The sample size for 2, the ones given the placebo, 270. Significance level is 0.05. Go to next. And we've got our proportions. About 7% of those who had Lipitor got infections, 10% who got the placebo got infections, pooled about 9%, z-score, and then our p-value is 0.46. We compare that to the alpha value of 0.05. We have a p-value of 0.46. This is much bigger. P is greater than alpha, which is a fail to reject. Okay. And when we go to the next screen, we will see we are not in the rejection region. Certainly, we're way out of the rejection region. You can zoom in on either side. The rejection region is with the zebra stripes. Our p-value gets way into the confidence interval area. It's a fail to reject. So we cannot reject it. So at this point, there's not enough evidence to say that there's a difference, which is good. It means that they're so close that we can't, there is not a side effect of getting infections. Again, we just don't have evidence for it. Maybe we need a larger sample size or something, but again, at this time, the way we've set it up, since we failed to reject, this could be a type 2 error, which is not as significant as making a type 1 error. All right, so then the last thing I want to show you is that this is where I've got these questions from. And if you go to this website, I think my size is going to be, I don't quite fit there, but what you can do, let me see if I can resize my, go, makes it a little bit better, I'll fit in there. You've got the questions, what we did. If you click here, you'll see the answer and maybe the explanation. If we scroll down a bit, we'll see the other ones that we were working on. Here's that 11 with the where they get their news. Again, if you click on that, it gives you some greater explanation. We did get a p-value of 0.005, and if we rounded it, it would have been 5.4. So you can use this sort of to reverse engineer questions, where you can take a look at the answer, take a look at the question, see how they got it. Here's that last one we did with the Lipitor. There's other ones in here. Anyway, a good opportunity to practice on some questions in a way that you can also take a look at the answers as you go. All right. Thank you very much.